Okay, more testing on the dreaded Yaesu. One rotator spins to the right slower and vice versa to the left. This rotor right here in front of me goes slow to the right. Now, my buddy Sean in Missouri told me that there's some problems out there, and I want to kind of go through some stuff. Now, I've got a pigtail hooked up to this thing, and I can put the probe on the positive wire, which is going to be the green wire, which the green wire goes to pin 4. And if I go from tie into pin 4 with the positive lead and take it to the case for the negative, that's my voltage. When I go left, I get 0. When I go right, I get 3.9. And then if I switch the leads over to the positive to the blue wire, which is going to be pin number 5, and I go left, I get 23.6, and to the left, or 23.6 to the left, negative 8 to the right. And this is my voltages when I'm checking it. Positive on the blue, negative on the green. I get 23.6 going left and right, I get 11.9. And when I switch the leads around, of course, the voltage just goes negative and positive, as you can see. Now, when I ohm check pins 4 and 5, I get 11.2 ohms. That's going to be the ohmage going through the motor and everything. And whenever I check pin 4 to ground, I get 496 ohms. And the same if I go pin 5. So that is slow to the right. Now here I'm going to pull this piece of paper out on the one that's slow going to the left. The test is basically almost the same. But my main concern is I'm not worried so much about the voltages, but now pin 4 to ground, I get 1.338K, and the same going the other way. And I got a 8.2 ohms through pins 4 and 5, where on the other one I had 11.2. Now let's go to the Yaesu 1000 that works perfect on this same controller. This is the tricky part. I've got the probe on the green wire, which is again pin 4, which makes it go right. And you can see when I've got the probe on the green wire, I got 0 volts going left and 23 volts going right. Now when I switch the leads around, it just crosses over. It's the same thing. 23 volts at pins 4 and 5. Now, when I ohm check pins 4 and 5, I got 9.7 ohms, which is in between the one that turns slow to the left and one that turns slow to the right. Now here's the kicker. When I go from pin 4 to ground, it's an open, and pin 5 to ground, it's an open. Now, I don't know if you guys are familiar with the insides of these things. They've got this noise circuit inside here. You've got a choke, a resistor, 2 caps, and there should be one more cap in there somewhere. I'm trying to look around the screen. Anyway, my buddy Sean in Missouri said that, see, these are like a through pass-through right here. Here's your 2 wires. It's either going to be -1 and positive on the other one to make it turn either way and reverses it. And it goes through there, and they put this little board on there. And I'm going to see if I can't find a pointer. Okay, here's a pocket pry bar. I love my terminology. Okay, if I can get this on here right and then show you. Okay, I've got the pocket pry bar on the terminal. They solder that board to those pins right there. And on the other side, it'd take me a little bit to figure out where that one is. It's right over here somewhere. I think it's right there. Anyway, when Yaesu solders those boards on there, I'm trying to figure this out. They solder the board to the pin. That's the only thing holding it in there. It gets a gob of solder that drops down and shorts out this plate right here. Now, I don't see it on this one, but that's one thing that Sean said was he would do a voltage check and he would get power out the case. And that's kind of what's going on with some of these. Of course, this one here, this 1000, is 0 and 0, as you can see. And like this one over here that's turning slow to the right, it's got 0 on that side. And then it's completely opposite over here. It's got 23 volts here and -8. In the same way with the other one over here that turns kind of funky. Anyway, I believe the problem is in here somewhere. Because the 1000 that works perfect has got 0 ohms between 4 and 5. And that would be the same as going through these two wires right here, because all they do is go through the end of rotation switch, and you can see that one comes out as a red and the other one comes out as a black, and I just stick it back in here so I've got a way to hold it. But they come out through here, go through the pass-throughs, and go to this noise suppressing board. And another thing my buddy Sean said was if you connect these wires right to the motor and bypass this whole thing, his was turning perfect both ways. So he's found that there's been gobs of solder that's dropped down from this board and hitting this plate. And another thing Sean said was if this thing was dangling like that, it would work perfect until, of course, you put it back down and then it grounded out. See, there should not be anything grounding between the motor and the case other than one of these capacitors in here somewhere. I don't know which one it is, but there is a cap that I think both of these caps here go to ground. And it's possible you could have a short in one of these. They're 47 PF or UF. That's 47,000 PF caps. Anyway, I looked up all that stuff on the website. But you can see the gappage down in there. The only thing holding this board in is the fact that it's soldered to the pass-through. So we're getting a little closer trying to figure this whole thing out. I'm honestly thinking now it's a problem in the rotator. Anyway, that's it for now. Once we figure this thing out, we'll update a video and make an adjustment on another video on what we found. Okay, 73's Scott's Rotor Repair.